Hi guys. So yeah, I'm Keith Robertson from XYZ Rail. Hopefully you can hear me okay. I'm regional manager for Scotland and also get involved in the plant innovations department on various innovations, but today I'm going to talk about our ALO protection system in a bit more detail. So I'm going to quickly, briefly talk through what it is we're trying to protect against. We'll then I've got a couple of videos to show what the system is, a bit of a time lapse of a demonstration that we've done for some clients. Then we'll talk a bit about compliance as well at the end. So as a bit of background, we were kind of working down in London about 4.5, 5 years ago, and we're challenged, when we're working ALO, we're challenged to come up with a solution that automated the ALO protection compliance in accordance with COP. So we set about working on that, and we come up with this what we're calling iSystems. At the time it wasn't version 3. Currently we're working to version 3 of COP 32 for ALO working. There's a few changes to that. The introduction of the 4 metre low performance zone for curved track is the biggest change. Previously it was 3 metres for everything. There's the introduction of the term exclusion distance, and there's also the previous COP had it as well, the cant allowance values as well to consider. So to kind of integrate that into our system to take account of this. There's various, the system that we've developed can be adapted to various scenarios. So for example, for version 3, COP 32, for straight track, you're allowed to reduce the low performance limit to 3 metres. Or if you know the cant and curve, then you could do a calculation to work out what that intermediate position needs to be for. We're looking at various systems for both low performance and high performance protection. At the moment we've developed the low performance version. As well as that scenario, the system also protects against, or gives additional assurance where ALO is not required to be documented in terms of can the plant foreseeably foul the line. And in that scenario is if the maximum reach of the plant plus the attachment can encroach within the high performance zone. That's when you need to consider additional don't know what you call it, additional mitigations for ALO. iSystems that we've developed essentially is a camera-based system that we attach to any bit of plant, and that allows the kit itself to work out where it is in relation to the track, and therefore work out what its safe exclusion zones are in virtual walls. It's a system for use on civils plant rather than for RRVs. RRVs have already got various well-known systems for high performance protection, so you don't need that. This is all for civils kit working off track, so that could be excavators, dumpers, rollers, track chippers. It works on all as long as you can mount it. The system itself, what is it? It's essentially a 2-part camera system. One part of the cameras detects, it's basically infrared, it detects high-vis materials such as high-vis jackets or retroflective cubes as we use for eye markers. There's also then a measurement camera as well that can measure what the objects are in front of it. And we basically combine those 2 cameras to make a system that detects a boundary and then forms its own virtual wall in accordance with that boundary. It's the same camera systems that are getting used to kind of make driverless cars, and we're kind of leaning on that technology, and we're developing the software internally at XYZ to allow us to kind of put it into an ALO scenario. The way that it works on site, so the system relies on what we call eye markers, which are 300mm retroflective cubes. The cameras pick up those cubes and detect 3 cubes, or a minimum of 3 cubes in a line, and that allows it to form a virtual wall boundary position. And that could be offset from the track. So for example, you could have the eye markers, let's say 2 meters from the track, and we could have the virtual wall or the machine automatically putting an extra meter onto that to get 3 meters or 4 meters of what the intermediate position is that I talked about before. When it recognises the markers, the system then, the system's got a model built within it, so it knows, the machine knows where each part of the machine is based on what the cameras are seeing and based on what the undercarriage is doing. If the system can't see 3 markers, then it essentially stops working. So it's like it fails to safe. So if the markers are either obscured or it runs out of a line of markers, then it can't continue to move closer to the track. I've got a video next that kind of describes the system in a bit more detail, what the benefits are and so on. So just watch this in a second. Hopefully it'll play it. So the system in the video there was our iSystems, what we're calling iSystems 1. So that's our basic system, and that's for protecting machines from entering the foreseeably foul scenario. So it works at full reach of the machine, or as it's shown in the picture there, you could put it on dumpers to work closer to, like parallel to the boundary as well. The system's got the four cameras pointing in, to cover all 360 degrees of the machine for camera detection. That's set up on the machine either at site or before it comes to site. On smaller bits of equipment, for example, like we've shown on that graphic there of the dumper, we can mount the cameras on a pole on top of the cab or on top of the upper structure of the machine as well, to free up space. It's particularly handy on track chippers and so on. Once it's set up, we set up the eye marker cubes either onto fences or pedestrian barriers or Vortoc fence. And then once that's set up, we can then calibrate the cameras to what the machine is and to where the fence is, and the system does the rest after that. It's been one of the biggest challenges for us in developing the system, is understanding that calibration issue and being able to refine that enough to be confident with it in these scenarios. Should be another video here that will show you, which is what we're calling iSystems 2, which we'll go into in a minute or two. iSystems 2 in the next video, although it's on we've got it mounted onto one of the road RRVs at the moment, and the only reason it's on that is because it's got a triple boom and it's a bit more awkward for us to test the system. We've deliberately done it for that reason. So this is a time-lapse video. Yeah, so this is a time-lapse video of iSystems 2 working on a triple boom. As I say, it wouldn't be normally used in an RV; it'd be used on an off-track machine. So you don't need to stop and reposition or reset any levers. I know there's other systems out there that rely on locking the forward reverse motion. As you'll see, the undercarriage could be pointing in any direction, and it will stop the machine. It will also stop the machine on the tail swing as well when you get too close. So it just means that the production on site can be kept to a maximum while still automatically protecting against the ALO boundary. And in that scenario there, the eye markers were set at 2 metres from the track-ish, and the machine was, you could see the machine was already stopping about half a metre to a metre beyond that, which was taking the additional safety distance for ALO protection. So the systems that we're developing, so we've started off with iSystem 1, which is up and running, being used on our sites. So that works at full reach of the machine, which is good, but it's not too handy when you're trying to dig drainage or try to do work close to the boundary line. So we decided that we looked to how we could improve that, and we teamed up with ProLec Rail to incorporate machine control into the system as well. So the current version of iSystems 2, which you see in the time-lapse video, that's incorporating our iSystems camera system and ProLec's machine control system. So essentially our cameras are feeding a data link into ProLec's virtual wall system. So instead of where you normally type in a virtual wall, the camera's doing that automatically. So when the machine's moving, you can see the virtual wall moving in within the display inside the cab. Primarily it's for increased productivity when you're doing excavation work adjacent to the high performance zone. At the moment, we've got that on the Liebherr, the XRRV Liebherr there. We've had it demoed and tested on some of our sites down at Newton Heath and up in Scotland, and it seems to be working well. There's a few kind of like teething troubles where you've got like personnel walking around or other items of kit moving around. We've had to work quite hard and quite long to try and resolve those issues. You tend to find they work quite well when it's all static objects, but as soon as it's moving, it becomes a bit more challenging, just for the cameras to differentiate what's what. The next development on iSystems is iSystems 3, as you can see there. So iSystems 3 is essentially an iSystems 2 but high performance version. And the way we're going to achieve that is essentially the camera system will essentially remain the same. There'll be some calculations and proofy calculations to be done documentation-wise, but it'll be an upgraded version of the ProLEC machine control system, which will be a high-performance version, which will allow us to, or ideally, or the plan is, it will allow us to get approval for high performance. Benefits of iSystems 1, as I say, it's enforced machine control for either for where you're working at full reach of the machine or where you can't foreseeably fill the line. It can be stored on any bit of plant. All of our iSystems have got data loggers as well, so it means that we could review the data and check how heavily the operators are relying on the system, rather than having it as a backup, because that's obviously one of the dangers that we see, is that operators get too complacent to having iSystems on the machine and start relying on that boundary to stop the machine, whereas really you want it to be a backup. So that allows us that should allow us to train or coach your operators to not rely on that too heavily. iSystems 2 benefits, as I said, is it allows us to work closer and up to parallel to the high performance boundary. For example, drainage runs and so on is a lot more productive working over end of the machine than over the side. Can be fitted to any machine. So again, iSystems 2, the way we've got it set up, could fit it to mono booms or triple booms. We've not done it for bendy booms yet, because that's just another complexity that we don't need just now, but that'll probably come in the future, I would say. There's also still no approval required for this system in accordance with COP 32. And iSystems 3, the main benefits for iSystems 3 is allow far greater productivity on daytime working. So it should hopefully reduce nighttime working, reduce costs, increase safety. There's numerous benefits to that once we get that going. A question that we always get asked is approvals, or what approvals we need for iSystems. Essentially for iSystems 1 and iSystems 2, because they're low performance systems, we don't need any approvals, as long as we could confirm that the system works at the start of every shift. When it comes to iSystems 3, we do need approval, and we're currently going through product acceptance for iSystems 3 as well. We're actually putting iSystems 2 through product acceptance at the moment, even though you don't need it, just to get a head start on iSystems 3 and flush out and do it as kind of like an early trial run of what's going to get flagged up. A couple of extracts from COP 32 that states what the requirements are for high or low performance. So essentially, a high performance system needs to be compliant to 1530 or have approval from Netrail's infrastructure manager. Low performance systems are any other system that don't meet that, so that could be mechanical slew locks, other low performance slew restrictors, and so on. So iSystems 1 and 2 fall into category 1 there, and iSystems 3 falls into category 2. Just a little bit about controls. When you're operating over 4 metres from the nearest operating running line, so that's on a curve, or 3 metres on the straight. The benefit of iSystems as well is that because you've got the eye markers and you can physically see them on site, it gives confidence to everybody on site that there is a system set up and you can see it. There's other systems that rely on GPS surveys and so on, but it's all invisible, so you can't really see if you can't tell where that virtual wall is. Whereas with iSystems, you could go on site, anybody could rock up on site and see exactly where the markers are, or they could spot if a site conditions change and the markers are now too close, if there's been a track slew or whatever, and it's also then quite easy to amend the position of those markers as well to change it. When you're operating less than 4 metres to the running line, it's just an extract again there, just to say that it needs to be a high performance movement limiting device. And as I say, that's not available yet, but it's, that's the next innovation. There's a Wii Slide there. the only reason I include that slide was in case these packs get sent out to everybody and you could go and refer it. The way we're going to operate iSystems in UK Rail is essentially as a managed service. So we'll provide, we'll install the iSystems onto the machine. We'll install the ProLec machine control block, hydraulic block, and the controller onto the machine as well. Then remove it again if it's not our machine. Remove it again if it's a third-party machine at the end of the project. And we'll also set up and manage the iMarker setup as well. When ALO first came out, there was various calculator sheets that NetRail produced that had various errors in them. I think there was well-known errors within the calculation sheets. So, but we do feel there's a benefit in having something like that to give a bit of automation to the ALO planning. So, as part of iSystems, we've also developed, which is downloadable on our website. We've also developed like a selection tool. So if you're planning a project and you're thinking about using ALO or ideally iSystems, then you could go on that. You could put the site conditions in, and that will work out based on the COP32 standard, COP32 code of practice, what iSystem would be more suited for the project, or if a possession is required and you physically can't do the work. There's also a wee scenario calculator at the bottom as well there to check. You can put in what the site conditions are, and it will tell you if it's cheaper or more expensive to use precast barriers, for example, or possession working. And that can be found on our website if you're interested. I think just before I come off, it was listening to Nick Millington's introduction earlier on. Another innovation that we're taking with the iSystems, which is going to be coming after we get the ALO protection system finished, is a personnel protection system. So because our cameras work out the distance based on retroflective materials, they also pick up high-vis clothing, and they also pick up any high-vis signage on other machines and delivery wagons and so on. So what we found during the testing is that our system is actually really good for protecting against plant on plant and plant on personnel clashes. So we're looking to, and again working with ProLec, we're going to look to produce a system that works out where people are based on round about the machines, and then automatically derates the machine or slows the machine to allow people to safely work in amongst the machine working. So for example, like a machine controller or a banksman taking a pin out to change a bucket or hydraulic hoses, our personnel protection system will be able to know that person is there at the jib of the machine, and slow the movements of the machine to a safe level to still allow the operator to wiggle the bucket to get the pin out, which is always going to have to happen. So that's going to be a follow-on as well, but it's not ready yet. We've got a prototype on our ballast undercutter, but it's not quite ready yet. So just as a wee side note, I suppose. That's it from me. Thank you.